we are going to study enthalpy of physical transformation. The first physical transformation or physical change that we are going to consider is phase transition. Let us first understand what do you mean by phase transition. Let us consider that you have a substance in one particular phase. Phase means physical state, and you keep the substance same, no change in the substance at all, but you bring it into some another phase. Then this process is called as phase transition. Whenever phase transition takes place, either some amount of heat is given out or some amount of heat is absorbed. The amount of heat that is given out or absorbed is called as enthalpy of phase transition. It is called as enthalpy of phase transition. Whenever a phase transition is taking place, you have to remember 2 points. Number 1, phase transition always takes place at constant temperature and pressure. Means phase transition is carried out at a constant pressure, and when the phase transition is taking place, temperature should not change. And the second point that you have to remember is when the phase transition is taking place, there should be no change in chemical composition of the substance. So what is enthalpy of phase transition? Enthalpy change taking place during a phase transition at constant temperature and pressure without undergoing any change in chemical composition is enthalpy of phase transition. So what is enthalpy of phase transition? It is the enthalpy change taking place during the phase transition of a particular substance at constant temperature and pressure when there is no change in chemical composition of the substance. The first phase transition that we are going to take is fusion. Fusion means a process in which solid gets converted into liquid. When a solid gets converted into liquid, some amount of heat energy is absorbed. The amount of heat energy absorbed during the process of fusion is known as enthalpy of fusion. Enthalpy of fusion is denoted by delta fuse H. Let me give you a very simple example. Suppose I have 1 mole of solid water, that is ice, and I want to convert it into liquid. Solid gets converted into liquid, so this is fusion of ice. When fusion of ice is carried out at 0 degree Celsius, the enthalpy change is found to be plus 6.01 kilojoules, and this is at 0 degree Celsius. So during the fusion of ice, whatever enthalpy change takes place, this enthalpy change is nothing but enthalpy of fusion of ice. So how do you define the term enthalpy of fusion? Enthalpy of fusion is defined as the enthalpy change taking place when 1 mole of a substance, see here, compulsory it should be 1 mole, when 1 mole of a substance in the solid state goes into the liquid state at constant temperature and pressure. The reverse of fusion is freezing. In freezing, a liquid is converted into solid. During freezing, some enthalpy change takes place. Enthalpy change taking place during freezing is known as enthalpy of freezing. Enthalpy of freezing is denoted by delta freeze H. Let us take the same example. What is the example? I have 1 mole of liquid water and I convert it into ice, that is solid water. These two processes are reversed. So the enthalpy change taking place will be same, that is 6.01 kilojoules. But here heat is absorbed. Here in the reverse process heat will be released again at 0 degree Celsius. And this minus 6.01, that is the enthalpy change taking place during freezing, is nothing but enthalpy of freezing of ice. So we can say that fusion is an endothermic process, whereas freezing is an exothermic process. Now, the second phase transition that we are going to consider is vaporization. Vaporization means you will have a substance in liquid state. You have to convert it into its vapors. When a liquid gets converted into its vapor, some enthalpy change takes place. This enthalpy change taking place during vaporization is known as enthalpy of vaporization. Enthalpy of vaporization is denoted as delta vapor H. Let us take a very simple example. Again, suppose I have 1 mole of liquid water and I want to convert it into its vapors. Then this process is known as vaporization of water. When 1 mole of liquid water gets converted into its vapors, it is observed that the enthalpy change taking place is plus 40.1 kilojoules at 100 degree Celsius. What does this mean? I have taken 1 mole of liquid water, I am converting it into its vapors at 100 degree Celsius and at constant pressure. The enthalpy change is, that is heat absorbed, is 40.1 kilojoules. And this enthalpy change is nothing but enthalpy of vaporization of water. So enthalpy of vaporization of water at 100 degrees Celsius is plus 40.1 kilojoules per mole. Remember, if I carry out the same process at a different temperature, then the value of delta H will differ. So how do you define the term enthalpy of vaporization? Enthalpy of vaporization is defined as the enthalpy change taking place when 1 mole of a liquid is converted into its vapors at constant temperature and pressure. The reverse of vaporization is condensation. Even during condensation, some enthalpy change takes place. Enthalpy change taking place during condensation is enthalpy of condensation. Enthalpy of condensation is denoted as delta condensation H. Condensation is exactly reverse of vaporization. So, in condensation, I will take 1 mole of a substance like water in the gaseous state and I will convert it into its liquid. When 1 mole of water vapors are converted into 1 mole of liquid water at 100 degrees Celsius, enthalpy change is equal in magnitude, that is 40.1 kilojoules, but it is reverse in sign. Okay, this will be at 100 degree Celsius. This enthalpy change taking place is known as enthalpy of condensation. So, enthalpy of vaporization is an endothermic process, whereas enthalpy of condensation is an exothermic process. Now, the third phase transition that we are going to consider is sublimation. sublimation? Sublimation is the process in which I will have a solid. I will directly convert it into its gaseous state, but naturally at constant temperature and pressure. The substance to be taken is only 1 mole. When sublimation takes place, some enthalpy change takes place. That enthalpy change taking place is known as enthalpy of sublimation. Okay, enthalpy of sublimation is denoted as delta sublimation H. Let us take an example. Suppose I have ice. Ice means solid state of water. I directly convert it into water vapors at 0 degrees Celsius. It is observed that the enthalpy change is plus 50.8 kilojoules. It is plus 50.8 kilojoules, but naturally at 0 degrees Celsius. So at 0 degrees Celsius, when 1 mole of ice is converted into 1 mole of water vapors, 50.8 kilojoules of heat is absorbed. Means sublimation is an endothermic process. And this enthalpy change taking place is known as enthalpy of sublimation. So how do you define the term enthalpy of sublimation? Enthalpy of sublimation is defined as the enthalpy change taking place when 1 mole of a solid is directly converted into its vapors without going into the liquid state at constant temperature and pressure. Remember, we do not have a reverse process of sublimation. That means any gaseous substance cannot be directly brought into the solid state. The next phase transition that we are going to take is sublimation. What is sublimation? Sublimation is a process in which I have a substance which is in the solid state, and I am going to directly convert it into its gaseous state without taking it into the liquid state. When this process of sublimation is taking place, it is associated with some enthalpy change. This enthalpy change taking place during the process of sublimation will be called as enthalpy of sublimation. Enthalpy of sublimation is denoted as delta sublimation H. Let us take an example. Here I have 1 mole of solid water, that is I have ice. I want to carry out its sublimation, means I am going to convert it into water vapors. Say this conversion I carry out at 0 degrees Celsius. It is observed that at 0 degrees Celsius, when 1 mole of ice gets converted into 1 mole of water vapors, 51.8 kilojoules of heat is absorbed. So the enthalpy change is found to be plus 51.8 kilojoules at 0 degree Celsius. And this enthalpy change is known as enthalpy of sublimation. So sublimation is an endothermic process. Remember, we do not have a reverse process for sublimation. Means any substance into the gaseous state can never be directly converted into its solid state. It has to go into the liquid state and then come into the solid state. The process of sublimation takes place in 2 steps. In order to understand this, let us consider sublimation of ice, that is conversion of ice into water vapors carried out at 0 degrees Celsius. In sublimation of ice, the first step is conversion of ice into liquid water, which is nothing but fusion. When we studied enthalpy of fusion, we have seen that at 0 degrees Celsius, enthalpy of fusion of ice is 6.01 kilojoules per mole. The second step is conversion of liquid water into water vapors. This process is nothing but vaporization. We have studied during enthalpy of vaporization that at 0 degrees Celsius, the enthalpy of vaporization of water is 45.07. When you add these two reactions, what you get? You get H2O liquid will get cancelled because it is formed in the first step and used up in the second step. So the final reaction becomes H2O solid gives H2O gas, which is nothing but sublimation. Thus, addition of fusion reaction and vaporization reaction gives us sublimation reaction. So, in the similar manner, addition of enthalpy of fusion and enthalpy of vaporization gives us enthalpy of sublimation. So, in this case, addition of these two values is 51.08. So, enthalpy of sublimation is 51.08 kilojoules per mole. Remember, this is at 0 degrees Celsius. So, what does this follow? This follows that enthalpy of sublimation is equal to enthalpy of fusion plus enthalpy of vaporization. The entire process can be represented with the help of a very simple figure. See, in sublimation you have solid which will go into the gas. The enthalpy change is enthalpy of sublimation. So the first step is fusion. Its enthalpy change is enthalpy of fusion. It results into liquid. The second step is vaporization. Enthalpy change associated with it is enthalpy of vaporization, which results into a gas. Thank you. Please like, comment and subscribe for the further videos.